Hello, this is Gary Martin. The screen captures from my CS156 Python 1 class. And what I hope to do today is review some of the PowerPoint slides I was unable to do because I was absent from class. I guess being sick and in a hybrid class does afford at least one luxury in that I'm able to take and perhaps do some stuff with video and put it on the internet so I can keep you guys up to date with what we would have talked about. If you have any questions on these topics, identifiers will be on the test, so will functions. Importing is an example of that, one of the examples put out there for you. That will not prominently be on this test at all. And also I was going to ask you guys if there's any questions for the books, the videos, Code Academy, etc. These questions still apply. If you have any comments or anything you want me to comment on or question about one of these, just let me know. Chapter 5 is a lot about decision structures. And because it's about decision structures, it reviews things like operators, Boolean expressions, and also logical operators. A review of operators, we've looked at arithmetic operators so far, the plus, the minus, the multiplication, the division. They introduced another operator called modulus, and modulus is used to take the remainder of a variable or an identifier. And what it does is if I was to divide two numbers and I want to know if it was even, modulus would come back with 0, no remainder. If they were an odd number, it would come back with a fraction or some remainder, and I could then flag that. Either an if statement or the standard thing I use modulus for is when I'm calculating leap year. Boolean expressions are very important to all programming. Basically, it's an expression that evaluates true or false. That's where the word Boolean comes from. It's an expression, so it looks a little mathematical. It's usually comparing two things, either a couple of identifiers, a constant identifier, and it's normally joined by a double equals, which is the equity operator, greater than or equal to, typo there, greater than or equal to, less than or equal to, greater than, less than, or not equal to. When these two expressions are placed between a couple of identifiers, the logical expression will test to determine if it's true or false. If it's true, in the case of a decision structure, it branches one way, and if it's false, it branches the other. So the way this manifests itself for the most part is with decision structures primarily, and then secondarily with repetition structures, which we'll cover at a different time. But an if statement is your classic example of a decision structure. And basically what you have is you have an if statement, which is a keyword right here. Python uses parentheses. You don't have to use them. It's a good idea because it kind of groups everything. This would take the identifier number A, which currently has a value of 5, and use the equity operator to compare it against the value of a numeric constant 5. The important thing here is it also has to have this colon at the end. The colon indicates that the code block follows, because if this is true, it's going to take this code block. Okay. If it's false, it's going to take the else or the other code block. You'll also see a colon there. So if number is equal to 5, which it is, it's going to check also to see if character B is cat, which it isn't, it's dog. So in this case, the answer would be answer is not cat. The pathing or the branching depends on the Boolean expression. In this case it was true, but in this case it was false. Whether or not you have a false option is up to you. Sometimes they're necessary, sometimes they're not necessary, so therefore they're optional. Some other things that you can run into with most programming languages is the nesting of if statements, which means that an if branch has another if branch as part of one of its true or false tests. This is how programs can make sophisticated, complex decisions. This is all fair game, it's all legal. There's another thing that Python does called elif. And elif is simply just an if statement that has elif all the way down. And typically what it's doing is just evaluating different values against the same identifier. If it's a 5, do this. The next would be if a 4, 3, etc. There's some examples of that in the book, and if you go on Google or any one of the resources we have in class, you'll even see some more examples of that. A change if statement is elif. A nested is the one I just showed you. Else is optional. Recursion is kind of a tough nut to crack, at least in this video here. I'm going to have to demonstrate in the class. When I put this PowerPoint together, my plan was to demonstrate it with code. I don't have that code right now, so I can't do that. But basically, recursion is a function that calls itself, which most of the time, when anything calls itself and has no endpoint, it's considered infinite or endless, and it's a bad thing. But recursion does have an endpoint, and it's used to kind of count down. The classic example that I use for recursion is I used to write a program, which I'll show you guys, that basically searches for a file in a folder in Windows. Now the problem is with Windows, you never know how many folders and subfolders you might run into. So if you're searching down a particular folder line, the program literally has to go to maybe 7 or 8 different folders looking to see if it can find the file that you're searching for. since it could be 4 or 5 files in one search and maybe 1 or 2 files in the other, you really can't say search this many of loops or this many folders. It has to be recursive. In other words, I have to keep on searching until it finds the endpoint. These are tricky, and I'll explain these in class next week. Excuse me. The other thing that's in the book is it talks about raw input. And raw input has been deprecated, and it does not support in version 3. You'll see some examples of it, some older code. This book has a lot of 2.7 code in it. We now use input. Both of these built-in functions return a string, and you've seen it already in class where we've cast these into an integer or a float if we've tried to do math with them. It was brought up in the book, so I thought I'd just quickly touch on it for you guys today. Look over the class assignment solutions. They're out there in the S drive. They're also in Canvas. Some of the highlights in it, I'm using some import statements. I'm using built-in functions, a data object, some IP processing, and some functions. It does represent the kinds of topics that are supposed to be covered in this chapter. And, along with what you'll find in videos, Code Academy, and the book, this is just one more mechanism of getting some more information. And that's it for now, guys. It's a brief summary of the class, 6 minutes worth of video to cover a half hour or an hour and 10 minutes of class. But I think we'll pick it up next time. I'll review it again. I'll show you some examples, and we'll go from there. I apologize for not being today. Unfortunately, this cold got the best of me, and I'm not sure it would have been, one, I might have given it all to you, and I don't think that would have been a good thing either. So we'll see you next Tuesday. The test will be available on Friday. Bye.